Hello student. So today we will discuss about heat conduction in solid having infinite thermal conductivity. It is also known as lump parameter analysis. So before that we will understand what is infinite thermal conductivity. So suppose here we have a plate. Here we have a plate, and if plate having a thickness, if thickness is very less, then we can consider that it has a infinite thermal conductivity, because whatever heat coming out from this body directly it get drastically it will get rejected into coolant. બરાબર, જે હીટ આવશે તરત જ કુલન્ટમાં ટ્રાન્સફર થઈ જશે. તો જ્યારે થિકનેસ ઓછી હોય ત્યારે તમે આ એનાલિસિસ એપ્લાય કરી શકો અને તમે આની કંડક્ટિવિટી ઇન્ફાઇનાઇટ છે એવું કન્સિડર કરી શકો. યુ કેન નોટ એપ્લાય ધીસ થિયરી if our block is like this, if block having a higher thickness, so you cannot apply this theory. Clear? So I hope you understood this. So for that let us assume one of the body. Here we have a random shape body. This is random shape body which having mass m, which having specific heat c, which having temperature T. Outside temperature means coolant temperature is TA. What is convective heat transfer from this body to coolant, and what is convective heat transfer coefficient H. What is area of this body? A. So this we will have to remember. Now we know that what is value of heat which is coming out? HA T minus TA. This is heat coming out of this body, and because of that what will happen? MC, temperature of this body get reduced with time, and here we will have to write down minus because temperature is decreasing. So MC dt by d tau. Now what is M? We know that rho into V C dt by d tau is equal to HA T minus TA. Now what we will have to do? Now here we will have to separate temperature term and time term. So what we will do here? dt. So this is temperature term, and on another side we will have to write down term which are related with time. So here d tau. So now we will have to do integration. We will have to do integration here. So what will be the integration here? This will be ln t minus ta. What will be integration here? Minus HA rho Vc. Now what is d tau integration? That will be tau, and here we will have to write down C1. So now we will find out C1, but for that let us write down this equation 1. Now we want to find out C1, so you will have to apply condition. So one of the condition we are applying. So here at time is equal to 0. So initially temperature of this body is known as Ti. So let us apply this condition. Where you will have to apply? In equation 1. So let us change that term T. Here in place of T you will have to write down Ti, and in place of tau you will have to write down 0. So HA rho Vc, here you will have to write down 0 plus C1. So this is how you can get value of C1. So what will be the value of C1? C1 will be equal to ln Ti minus Ta. So let us put this value here in equation 1. So our equation 1 will become ln T minus Ta is equal to minus HA rho Vc tau plus ln Ti minus Ta. So here what we will do? ln T minus Ta minus ln Ti minus Ta is equal to minus HA rho Vc tau. So here what we can write? ln T minus Ta divided by Ti minus Ta is equal to minus HA rho Vc tau. So here suppose we want to remove this ln, so Ti minus Ta is equal to e raised to minus Ha rho Vc tau. Clear? So this will be the equation. Now this is the equation from or by use of which we can find out temperature according to time. Suppose we want to find out temperature after 5 seconds, after 10 seconds, so that we can find. So here you can see that here we will have to replace time, and according to that we can get temperature. So this was about this equation. Now we will find out instantaneous heat transfer. Instantaneous heat transfer. Instantaneous means at the starting. So here again same formula we will apply, dt by d tau. Clear? So here we will replace mass with rho v c dt by d tau. Now here temperature, from where we will get temperature? From this equation we will have to write down temperature. Clear? So again by this equation let us write down temperature. T minus Ta is equal to Ti minus Ta e raised to minus Ha tau divided by rho v c. This is our equation. So from that T would be equal to Ta plus Ti minus Ta e raised to minus Ha tau divided by rho v c. Clear? So now this temperature, this value we will have to put where? This value we will have to put here. So let us write down again that equation, that Qi is equal to rho Vc d by d tau, and here what we can write? Ta plus Ti minus Ta e raised to minus Ha tau rho Vc. Clear? So now we will have to do differentiation. So differentiation rho Vc, differentiation with respect to time. So here we cannot differentiate this term, so directly we will have to differentiate this. So Ti minus Ta. Now what is differentiation of this? Now we know that differentiation of e raised to ax is equal to a e raised to ax. Now these we know that differentiation of e raised to ax is e raised to ax into a. So same way here we will have to, what we can write down? So initially we will have to write down this minus Ha tau rho Vc, and again here we will have to write minus Ha rho Vc. So here what will happen? Rho Vc get cancelled. So what will be the equation? Minus Ha e raised to minus Ha tau rho Vc, here Ti minus Ta. So this is equation for instantaneous heat transfer. Clear? So let us tell it as a equation A. Now we will find out total heat transfer. So in total heat transfer what you will have to do? Q instantaneous is equal to 0 to tau Qi dt d tau. Clear? So here what you will have to do? Just you will have to write down, just you will have to write equation of Qi here. So what would be that equation? Here equation would be 0 to tau. Here what you will have to write? Minus Ha, then e raised to minus Ha tau rho Vc, and here you will have to write down Ti minus Ta. So now again, now you will have to do integration. So what will be the integration of that? integration. So what will be the integration of e raised to ax? E raised to ax integration would be e raised to ax divided by a, that we know. So again we will do integration. So minus ha, इसको हम बाहर ले लेते हैं अभी. तो इंटीग्रेशन किसका करना है हमें? सिर्फ इसका ही करना है. ई रेस टू माइनस एच ए टाउ रो वी सी, और नीचे क्या आ जाएगा? माइनस एच ए डिवाइड बाई रो वी सी. ये एच ए तो कैंसिल हो जाएगा यहाँ पे. क्लियर? तो फाइनल आंसर क्या रहेगा हमारा? फाइनल आंसर हो जाएगा रो वी सी, उसके बाद ई रेस टू माइनस एच ए टाउ रो वी सी, और यहाँ पे टेम्परेचर रहेगा टी आई माइनस टी ए. सो आई होप यू अंडरस्टूड दिस. सो दिस इज इक्वेशन ऑफ टोटल हीट ट्रांसफर फ्रॉम 0 second to whatever you have defined tau. Clear? And that initial was our instantaneous heat transfer. So I hope that you understood this. So thank you all for listening me. Next time we will discuss one another theory.